Okay, well this video is following up on solving more equations here for algebra students. Hopefully, again, at this point you've studied how to solve one-steppers and two-steppers, maybe even things with some simplifying going on. Now let's talk about kind of a tricky task. What about if an equation has a variable on both sides? It just adds a little bit of extra trickiness, but really if we think about it, the ideas are going to be the same. So we'll keep it fairly simple here. First of all, we've got this nice long equation up here up top. We're going to start this the same way we would for any equation that has multiple steps. First thing I'm going to look for is, can I simplify anything on both sides? So I notice those sets of parentheses there. Looks like a great opportunity to maybe do some distributing over here on the left, maybe a little distributing over here on the right. So again, that's what I'm going to do right off the bat. I'm going to distribute that 4, making 4 minus 4x. Don't forget the plus 3 is still there, so just carry that one down, is equal to, and again, distribute the negative 2, causing that to be a negative 2x, and now a minus instead of a plus, minus 2. Over on the left, we also have a couple of like terms. Notice I see those x to the firsts going on. So I can add those two, not doing anything fancy. I'm just adding the like terms. They're on the same side of the equation. So negative 4x, don't forget that's minus 4x plus 3. Well, negative 4 plus 3 is just negative 1 x there. So I've got that 4 from the front, minus 4x plus 3x is a negative 1x left over. And again, I've still got negative 2x on the other side and a minus 2. Now you might be saying, well, minus 2x was like terms as well. But remember, we're separated by that equal sign. There's nothing I can do there as far as adding like terms. But now that does bring us to the next step though, and this is the big step in this video. If I have x on both sides of my equation, that's going to be pretty hard to solve, right? Get x totally by itself. Pretty hard to solve for x when there's multiple x's. So the next thing I'm going to do is move x either from the left over to the right or from the right over to the left. And it's totally your choice. I went ahead and said, well, hey, if there's a negative 2x on the right side, why don't I just add 2x, right, on both sides? Basically allowing me to say, again, that minus 2x on the right and the plus 2x that I put in there will cancel each other away. And you'll notice that minus 2, again, just carried down here on the right. Over on the left side, again, we still had positive 4, but a minus 1x plus 2x, right, like terms, is going to be a positive 1x left over. Again, you could still have coefficients, just happens this time. Negative 1 plus 2 would be a positive 1x. And then, hey, look, we only really have one more thing happening to x. Now that x is kind of the only one in there, the only variable left over, let's try to get it by itself. So now let's isolate. If I add 4, or sorry, it's already adding positive 4. Let's go ahead and get rid of that by saying subtract 4, right? 4 minus 4 will cancel down to 0, and 0 plus x is x. Negative 2 minus 4 would be a negative 6, and we have our answer. And again, you can always take that negative 6, plug it back into the original equation, right? Or maybe type that whole left side into your calculator with negative 6 filled in. Type that whole right side in with negative 6 filled in. Make sure you get the same answer on both sides. Let's take a look at another example just to kind of see how this works. So let's walk our way through this one this time. Notice on the left, we've got a fraction, positive 2/5. So let's go ahead and distribute, right? We're going to distribute that 2/5 to both parts. 2/5 times 10. Well, 5 goes into 10 twice. Times 2 would be 4. Or basically, I believe 2/5 times 10 is 4x. And again, same thing. 5 goes into 15 3 times. Times 2 would be 6. Or you could say 2 times 15 is 30. Divided by 5 is 6, is equal to 18. Now remember, I'm going to take that negative 4. Don't forget the minus sign. If it helps, you could always say plus the negative 4, right, when you go to distribute this. But I'm going to take negative 4 times x and negative 4 times negative 3. So this becomes negative 4x or minus 4x, and negative 4 times negative 3 would be a positive 12. Well, I can add a couple of like terms on the right side there. So 4x plus 6 equals, I'm going to go ahead and write the variable first. So notice that's a minus 4x And 18 plus 12 would have been 30. And remember, they're on the same side of the equation, so we're just simply adding. We don't have to do anything fancy. In that case, let's go ahead and add 4x then, since I've got x's on both sides. I'm going to add to both sides to stay equivalent here. 4x plus 4x is 8x plus 6. And on the right side, the whole idea of doing that, negative 4x plus 4x cancels away, and we get just 30. A couple of quick steps then, another two-stepper left to go. Let's subtract 6 from both sides. 8x equals 24. And divide by 8. Close to the bottom of the screen here. X equals 3, I believe, is going to be our good final answer. Let's look at a quick word problem where something like this might come into play. A local gym offers 2 packages for yearly membership. The first one offers a fixed cost, so a one-time fee. So if I was writing this out, I would think fixed cost. I've got $50 that I'm going to have to pay right off the bat. But once you're a member, right, to be a member, plus $5 per visit, okay? So now we're going to add on $5 a visit. So again, a fairly small fixed fee, but again, we're paying $5 a visit every time we go. Or this other membership, right, the second plan is a $200 fixed cost, but it only costs you $2 per visit. So it's a lot more money up front, but you're not going to bring very much money every time you go. So if you go often, this could save you money, right? If we're not spending as much every time we go. So our question is, how many visits does it take for the second plan to be the better deal? Well, if I could figure out how many visits it takes for them to be equivalent deals, right, to cost you the same amount of money, then after that, the one that I'm paying less per visit on, right, should be the better deal. So let's figure out what would make these two plans equal. When do we break even, as we sometimes say it? Break even. When would the two plans cost you the same amount? Well, I notice I've got x's on both sides, so I'm going to go ahead and subtract 2x on the right and subtract 2x on the left. While we're at it, I kind of think later on I'm going to want to put that 50 and that 200 together. So since I didn't have any simplifying to do, why don't we go ahead and subtract our 50 on the left and therefore subtract the 50 on the right. The 50s over here are going to cancel. And 5x minus 2x, we're left with our x on the left side. 200 minus 50 is going to be 150. But again, the 2x minus 2x cancels. I got rid of the x's on the right, but I also got rid of that constant, right, that 50 on the left. And I'm well on my way. Last thing to do then is divide by 3. As long as we did the same thing to both sides, right? Divided by 3, kind of like up top, we subtracted the 50s or we subtracted the 2x's. Perfectly legal. And that means 50 visits. If you take either plan, they'll cost you the same amount after 50 visits. Well, that means that when is the second deal a better deal? After, right? 50 visits. I would even say or more. The after kind of gets there. But in 50 visits or more, that second deal will cost you less money. Right? There we go. One last idea very quickly to talk about when we talk about equations that have variables on both sides. Sometimes those equations can come out to kind of funny answers. The first one being what we call an identity. What if both sides were equivalent when you got them done? So on the left here, I'm going to go ahead and distribute my 3, right? 3 times x is 3x, and 3 times 2 is 6. But now you'll notice, hey, wait a minute, I got the same thing on both sides. So if I go to subtract that 3x, right, to get those x's together, if I'm trying to move that 3x from the right side, right, I'm going to take 3x minus 3x. Well, hey, I got rid of it. But notice on the left, it actually cancels as well. We end up with a statement like 6 equals 6, which with no variable in there, there's nothing to be plugged in. That's true all the time. That's always true, right? Still a true statement, which means that the statements before it must have been also true all the time. They're identities. So our answer to that one then, right, if our equation comes out to identity, then the solution is, what can you plug in for x to keep this true, right? What answers would work? Well, all real numbers would work. Anything I plug in is going to make for a true statement. Over at the right, something else kind of funny happens. Notice we've already got it simplified, but let's say I was trying to get rid of this x on the right side over here, right? Because I want to get those two x's together. In order to get rid of a positive x, I'm going to subtract x. But again, if I do that on the left side as well, again, I run into that same problem. My x's are going to disappear. And notice this time we get 2 equals 4, which is kind of an absurd thought. So if 2 can't ever equal 4, then our answer to this one would be no solution. Okay? So again, if your variables disappear, if the statement is still true, your answer is going to be all real numbers. If the statement is no longer true, your answer is going to be no solution. It'll never work. Nothing would have ever made x plus 2 and x plus 4 into the same answer. I hope that helps you again with solving equations. If you have any questions, talk to your teacher. Otherwise, have a great day.